We're going to go ahead and get started with the next talk. I want to introduce Patrick. So hand it over to you, Patrick. Take it away.
All right, let's get started. So glad to be here. So what I want to talk about is, eBay has developed RaptorJS. And what it is actually just a modular JavaScript framework. Actually, we call it more of a system because it does a lot of different things. It does packaging, delivering code, things that just make it easier to build JavaScript applications. So I'm actually on the presentation and platform team at eBay. I've been with eBay for about a year. And before that, I've been working on JavaScript about as long as I can remember. Specifically, I like to work on bringing JavaScript to the server side and also just working on how you can organize your JavaScript code to make it easier to maintain, to make it more modular. So just to give you an overview of what I want to talk about today, I just want to explain to you why we actually created RaptorJS. So it wasn't easy to create RaptorJS. eBay didn't really want to do it. But when we tried to adapt different tools that were already out there to the eBay platform, we ran into certain problems. Sometimes it was performance problems. Sometimes it was the learning curve. Just all sorts of problems. So we just basically took and improved where we could. The other thing that I want to talk about is just packaging code. So as most of you probably already know, packaging code is basically the process of taking all of your code in your application and either bundling it up, possibly compiling it to actually make it so that it could be optimally sent down to the browser or whatever device you want to send it to. The other thing I want to talk about is the actual delivering of the code. So there's different ways to do this. You can do things asynchronously, blocking, non-blocking. And I want to go over some ways that eBay has made this easier. And then I also want to talk about actually writing code. So how you write your code also has a big impact on code maintenance and just how general constraints that you can get beyond if you just write your code in a certain style. So when you start to have complex JavaScript application, it can actually become very difficult to manage it because the dependencies are hard to work with in JavaScript. So unlike languages like Python or Java or Ruby, you don't really get a package management system. You don't have the concept of modules that have namespaces. You have to actually add all of those things to the language yourself as more of a functional approach. And so there's all different sorts of libraries out there that try to do this and make this easier. There's YUI, there's Dojo, there's CommonJS, there's asynchronous module definition, and all have their pros and cons. And so hopefully, the industry will converge on one thing, but right now it's kind of in a sad state. But if you're not even using a modular framework, what you end up having to worry about is all the dependencies in your code. So you have something that looks like this, where it's basically a graph of dependencies. And what makes this difficult is that dependencies can also have their own dependencies. So you have transitive dependencies, and dependencies aren't static. So they actually change over time. And if you're not aware of all those dependencies, and someone adds a new dependency, for example, then your code will break. Or if someone removes a dependency, you'll still possibly including the dependency in your code, and it's just wasted, right? So there's all sorts of things you have to worry about. And also, you have to worry about order. So if you write your code in, just say, traditional JavaScript, whatever that means, then you also have to worry about including things in the proper order so that things will load correctly. So we want to get away from all of those problems. So we want to make it so that you don't have to have, you create all these applications, we want them to be maintainable, and so other people can come and work on them very easily. And we don't think that you should actually have to worry about dependencies. So dependencies are something that when you create some reusable code, the developer of that code definitely has to worry about dependencies. But if you're just using someone else's code, the system should take care of the dependencies for you automatically. So what we want is a picture that looks more like this. So you're creating an HTML page. You know that you need this module. We'll call it a module. It basically provides some functionality. And that's what you add as a direct dependency. Now, if that module has any other dependencies, it'll pull those in automatically for you, and you don't even have to worry about it. And you can have dependencies be reused across different modules, and then each of those, that helps you avoid having modules repeat the same code over and over just because they didn't want to have to add a dependency. Because dependencies aren't bad. It's just that they have to be managed correctly so that you're not adding code bloat and you're not making applications hard to manage. So eBay is not completely unique, but we do have some unique requirements that necessitated actually creating RaptorJS. So one of the things that we wanted to be able to do was have adaptive packaging. And what that means is that there's all different types of environments that we want to have our code run in. So you have different types of devices, you have different types of browsers, you have IE6, IE10, and all of them are completely different, right? So how you package up your code and deliver it to those different environments is often going to vary. So you don't want to send code that's targeted just for IE6 to newer browsers because they may already have that functionality be native as part of the actual browser. And we also wanted to be able to have code that could adapt to both the server-side environment and a JavaScript environment, which also have their own different, definitely a huge amount of differences. So the other thing is that performance at eBay is critical. So every byte matters, and we want to be able to do all the things that Steve Souders says that you want to do, is that do immediate execution, download things in parallel, non-blocking, asynchronous, and not using document.write, all sorts of things like that. And we also wanted to support server-side JavaScript. So the reason server-side JavaScript is important is actually for two reasons. So we actually are exploring more of generating some of the presentation from the HTML on the server side so that you can have a common language on both the browser and the server. But we also want to use server-side JavaScript just for testing, because launching a browser just to go run your tests is actually pretty difficult. And oftentimes you don't actually have to do that, especially with tools like Node, which actually give you great testing frameworks that run on the server. There's even a simulated DOM, and I'll kind of just touch on that at the very end. But testing is one of the things that we want to make easy for JavaScript applications. We also wanted to keep things simple. So there's other tools out there, and trying to use them and bend them to the way that eBay needed it became actually very complicated. So developers didn't want to have to do that. So we were trying to see if we could actually simplify things in the areas of packaging and module delivery and writing code as well. And I mentioned earlier, performance is critical, so parallel downloading and immediate execution are two ways to really improve the performance of web applications, especially if you're over a low bandwidth connection. And we also, this is something I don't see actually too often, because most of us are probably familiar with just being very tied to build time tools for actually packaging up the code. But the problem with build time tools, and I'll go over this more later, is that you have to build everything up front. But if you're doing adaptive packaging, it may not even be possible, because you have so many combinations of how you can actually package up your code that how do you manage all those things? So with runtime packaging, you can defer that to the runtime so that you can actually do the packaging based on each type of user, which is actually really powerful. And we also had, this is kind of specific to eBay, but it also helps. So most of the frameworks out there that talk about modular JavaScript, or even just working JavaScript in general, just forces you to put everything on the file system. Well, we use Maven for actually pulling in artifacts into your project, and those are always delivered as jar files. And now, you could explode that into your directory, and that would work, and it's not a bad solution. But we thought it'd be nice to be able to have the code be packaged up and used in and added to your project as a jar file, and then easily be discovered so that it can load it on the server side, and then also used by the packager. So I'm not sure how many of you are actually familiar with like CommonJS or asynchronous module definition. Okay, so a good majority of you, I would say. So these two things are actually really helpful for creating code that's easy to maintain. And the only problem here, though, is that CommonJS, when it started, was specifically for the server side. And their coding style, how you code things, it won't actually work in the browser if you were to, unless you do all these weird tricks, or you have to translate the code. So then asynchronous module definition came along as a proposal to CommonJS to try to make it so that the actual way to define modules would actually work on both the browser and the server. But the CommonJS people didn't like this because they were very happy with CommonJS on the server. They didn't want to have to go change their code to accommodate the constraints of the browser. And that means typically you have to use asynchronous callbacks, which actually makes your code a little more complicated. So here's actually a comparison of CommonJS versus asynchronous module definition. So it might be a little hard to read, but you'll notice that the one on the top, that's CommonJS. And it's much shorter because it actually avoids a lot of boilerplate. But what's missing from CommonJS inside the code is the actual name of the module. So that context, so Node.js requires that you have one module per file. So the actual name of the module is based on the file name that it's actually in, so the file path. And if you were just to take that code, send it to the browser, it wouldn't work because it wouldn't actually know what module it belongs to. But the basic idea here is that you create a CommonJS module, there's an exports object, which it may look like a global, but it's actually a local because CommonJS is actually wrapping the code in a function block for you, and that exports is a local variable. So it's just a minor detail of CommonJS, but you basically export what things you want to make visible. And the really nice thing about CommonJS is that there's no use of globals whatsoever. So there's no pollution of the global namespace. You just simply register a module by name, and it resolves to the module implementation by the name, and then no one ever accesses it using part of the global namespace. And so AMD tried to fix some of the problems with the CommonJS, And the way they did that is that they put the name of the module into the actual code. So now you have a define method, and the first parameter is the actual module name. And the nice thing about this is that you can bundle up this module with other modules, and they will all just be registered based on their names. And it works on both the server. You can make it work on both the server and the client. But again, it's more verbose, so they didn't want to use it on the server. So there are tools that will convert their common JS code into AMD code and make it work on both environments. So just before I explain what RaptorJS, I want to just make it clear that it's not trying to replace jQuery, Backbone, or even Ember. It really is just a really core piece of functionality that can be used alongside any of those frameworks. It's not a UI framework. It's not a replacement module loader for Node. So we like using Node how it is. We don't want to change it. We wanted to create something that worked alongside Node and also Rhino or any other JavaScript environment. We didn't want to have to change those environments to meet our needs. It's not an MV star framework or anything like that. So what is RaptorJS? So RaptorJS is, so one piece of it is the actual packager and the optimizer. We wanted to be able to make it easier to package up your code. And I'll explain to you, I'll show you, it's probably easier to explain when I actually show you the code for what the packager looks like. But it also includes an asynchronous module loader. And most of you, I'm sure, if you've created applications, they have to load code after the initial page is already loaded. So there's you want a way to be able to include additional CSS and JavaScript code into your application. It also does have a really tiny JavaScript library that makes it easy to define, supports the required define module pattern, but it also makes it easy to create classes with inheritance. It also supports mix-ins and enums, just things that you were used to if you're kind of doing object-oriented programming. But it doesn't try to change JavaScript to make it something it isn't. So I'll show you the code. It'll make it more clear. It also has the module loader for server-side JavaScript environments, and we, out of the box, support Rhino and Node, but you can really support anyone. And if you don't know, I don't know how many people have used Rhino, but Rhino is a JavaScript environment that runs on the JVM. So if you're at a company that is really tied to the JVM, using Rhino can be very helpful. And there's going to be better JavaScript engines for the JVM in the future as part of Java 8 and things like that. So I think JavaScript is here to stay. It's going to be used in all sorts of environments. So we want to be able to leverage all of those environments when building applications. So the first thing I want to talk about is just packaging code. So packaging code is important. And in order to make the packager work, you have to be able to describe the dependencies of your module. So a module is just a piece of functionality. It's not just JavaScript code. It can also be CSS code. But we took the approach where every module has a package.json file. So for Node, Node already supports package.json files for modules, but you can also have in Node module be a direct one-to-one correspondence with the file itself. But in RaptorJS, the module resolves to a package.json file. And the reason this is important is that the package.json file actually has the information that tells the module loader or the packager how to actually handle the module. You can do interesting things when I'll show you how you can do the adaptive packaging, but it actually is more flexible than, and it gives you some rich metadata that you can attach to a module as well as describing the dependency information. So here's what a simple sample package.json file looks like. So the first part is just metadata. It's really only helpful for documentation. It's good to actually use that information if you're generating documentation that you want other developers to read. That information can easily be extracted. So the second part, this is new. So this is specific to RaptorJS, and that's the set of includes for your module. Now I wanted to be able to break up a module into one or more files, not just a single file. And I also wanted to have modules that could be just CSS code. And so this gives you the ability to list out all of your dependencies, the individual files that are part of your module in the order that they should be included. And now every time you include this module, it'll include those individual files. But the person using your module didn't have to know that your module consisted of 3 files or even 100 files. So it kind of makes it more flexible. But the next part is actually what makes it really more interesting, is that it supports extensions. So extensions is basically allows you to create conditional code. So when you package up your code, depending on which extensions are enabled or disabled, you can package up your code completely differently. So you'll often see frameworks come along that want to leverage jQuery, but they don't want to add a direct dependency to jQuery. So what you can actually do is, based on if you had the jQuery extension, for example, enabled, then you can include the jQuery specific code. Otherwise, you might, for example, include the YUI specific code. But you can actually then create a module that works in YUI, works in jQuery without having to duplicate all of the code that may be required. Yes, go ahead.
Can you specify version numbers in your dependencies?
So the version numbers, no. How version numbers are handled in Node.js and other kind of module systems is that they resolve based on relative paths. So you can actually have version modules relative to your modules. But versioning is something that it's both pros and cons. I mean, you don't want to send multiple versions down to the browser, but you probably want to catch it if your application has two different versions of the same module that need to be loaded. So I think that's something we probably should improve on, is actually be able to detect version conflicts and just add a packaging, show that as an error. But yeah, good question. So jQuery is just one extension. You can create any number of extensions. You can create extensions for browser feature detection, browser versions, like you can have extensions for IE10, IE6, all sorts of things. And also extensions for Node or Rhino, all the different environments. So the really nice thing about the RaptorJS packager is actually it's source code agnostic. So you can write your code however you want, using whatever style you want. And you can still use the packager to actually package up your code, to produce all the bundles, and to do all the translations of files into the JS and CSS code. This is not the case for many of the other tools. For I don't know who's familiar with Require.js and curl, and there's some other ones as well. But they all actually look at the source code to try to figure out what the dependencies of you are, what the dependencies are for that module. And it doesn't allow you to describe things like conditional dependency, because it just basically says, okay, we scanned the code and here's all the required dependencies that we found. We'll just make sure they always get included every single time, which is what we didn't want. Also, because the tools depend on a JavaScript file that actually inspects the code in a certain style, you wouldn't be able to create a package that is just CSS code. So in addition to just distributing JavaScript modules, we want to support CSS and also CSS combined with JavaScript modules as well. So the adaptive packaging, I just want to touch on a little more, is because depending on what kind of application you're creating or what kind of reusable code you're creating, it can be more or less important. But at eBay, we have a core set of modules that's used all across eBay. And because it is a very heterogeneous environment, we needed the modules to be able to adapt. So the landscape for JavaScript environments these days is pretty wide. You've got Android, iOS, Windows 8, HTML5, jQuery. You have no idea what's going to be loaded on the target environment. So we wanted to be able to have modules that load the specific code for the different types of environment, but still expose a common API. Just to give you an example of this, and hopefully this is a good example, but let's say you wanted to support JSON across all browsers. We all know that newer browsers have the JSON object natively. Older browsers do not. But if you have jQuery, it actually includes methods for parsing JSON. So you kind of want to be able to have your code adapt to those different environments. So if you're in an environment that has jQuery, just use the jQuery. Just have your implementation go directly to jQuery. But if you're on a newer browser, just use the native JSON object. And if you're on IE6, just send down a polyfill for the JSON. That way you can normalize JSON across every single environment. And you don't have to change your code. So the other thing that we want to support, and all the other packagers for the most part support this as well, is custom include handlers. So when the packager encounters a list of includes, you can specify just raw JS and raw CSS, but you also want to be able to refer to, let's say, mustache templates or handlebars templates, or CoffeeScript files or less files, and have those files automatically be converted into the JavaScript code and packaged up with the rest of your code automatically. So we wanted to make it as extensible and pluggable as possible, so you can just register your include handlers for the various types that you want to support, and then it'll automatically run that code to actually produce the final output. So this is also an area where the bundling system is something we improved on a lot compared to other tools. We wanted to make it very explicit what goes into each module. So it is driven by a configuration file where you basically list out all of the bundles that you want for your application. And just for each bundle, you just list what's included. So you just list the module. And if that module has dependencies, you can tell it to either go recursively, flatten all those, resolve all those transitive dependencies and put that into the package, or you can say just do don't actually be recursive and go look for all the transitive dependencies. But the nice thing about this is that these bundles are defined one time, and it actually are used across multiple pages. And so the thing that was really important to us was to have consistent bundles across all pages. So if, for example, you create one page that bundled jQuery with your code one way, and then you go to the next page, and the user goes to the next page in your application, and jQuery is bundled slightly differently, then you have to re-download jQuery. So we wanted to be able to have consistent bundles across the pages in your application. The other thing which I'll touch on in just a bit is that when the output of this packaging system, it produces a file for each bundle. And if the bundle consists of modules that have CSS code, then you'll have a CSS file. If there's any JS code, you'll have a JS file as well. But it also includes the checksum. So the checksum is nice because now you can use that as a part of your URL in your CDN. And if the contents of the bundle changes, you'll automatically reload it. And you can say cache permanently. So after you define all your bundles, you need to describe what dependencies are for each page. And you could do it via a configuration file. We don't actually do that at eBay, but this is just for making it clear this is also supported. You basically list out all of your pages. And for each page, you list your top-level dependencies. And those will automatically cause all your other dependencies to automatically be pulled into your application. But the nice thing is that if you refer to some module that's not part of a bundle or some file that's not part of a bundle, it'll just get dumped into a page bundle. So anything that's left over gets combined into a single page bundle for that particular page. So the nice thing that the packager does for you, in addition to actually generating the files that you need for the bundles, it actually generates the HTML markup that you can just include directly into your web page, so you don't have to worry about how everything was bundled. You don't even have to configure your HTML pages. It just generates the code exactly as it's needed that you put into your page, which is really handy. And you can use any server. You can use a server to actually include these generated files, or you can actually just have the packager update your HTML to inject those dependencies right into your code. Either way works. But I mentioned earlier the checksums is really important. So other tools don't do the checksums, but you want to be able to serve up your resources through a CDN, and you want to be able to say cache permanently. So you have to make sure that if the contents of the bundle changes, that the URL changes, and that's what the checksum gives you. And the really nice thing about all of this, this packager is because we just put all the dependency information in a package.json file, which is easy to read at runtime, the packager, which is what we're doing at eBay, can read this file to figure out exactly what needs to be included, and it doesn't have to go scan code at runtime. So it's really easy to have good performance. And of course, you cache all of this information. So you're not regenerating, parsing the package.json file for every single request. You do cache it, but it allows you to do packaging at build time and runtime. So I want to go over some of the benefits of build time versus runtime packaging. So there are some advantages to build time packaging. The first one is that you have very predictable performance in production because you're actually doing less work in production. You did everything up front. And for certain applications, that's a good thing, and it works well. It's also very easy to implement because that's what you're not dependent on any server-side tools. You don't have to worry about performance problems. It can be fairly slow, and it's not going to matter because it's all build time. It's also very reliable. Because you did all the work up front, you don't have to worry about things going wrong in production. You don't have to worry about files missing, bundles not being generated, that sort of thing. And there's no server-side support required. So this is probably why most tools out there use build-time packaging, is because if you create a library that can, and you do build-time packaging, it can be used in a Ruby application, a Java application, Python application. It doesn't matter because it didn't require any sort of server code to actually do the runtime packaging. But with that said, there are some advantages to runtime packaging, which are pretty huge. So I mentioned earlier that modules can adapt to each type of user. So sometimes it's not even possible, like I said, to generate all the different types of packages that you're going to need at runtime. And this is definitely very helpful. And also a good thing for developers that you're less reliant on build time tools to actually work with your application. So you'll see oftentimes where developers will have to change a file, then run the packager, which manually, and then it'll generate all the code, and then you go refresh your page. There are certain things that can make that easier. You can actually watch files for changes automatically so that they regenerate the files, but having less reliance on build tools can be very helpful. So now I want to talk about delivering code. So we've packaged up code, and now we want to actually send it down to the browser. So we want to support an asynchronous module loader, and so this allows you to bring code into the page after it's initially loaded. But we wanted to keep the implementation as simple as possible so that you're not sending down a lot of code for the loader just so you can start downloading the actual required JS and CSS code. Because the loader, really from the front end point of view, is just overhead. You don't want to it shouldn't have to be complicated. So what we went with is that we actually don't try to do resolving dependencies from the client side. We do all the resolving of dependencies on the server side. So we simply send down all of the URLs to the browser that it needs to load a particular module. So the client, all it has to do is say, okay, you want to load this module? All right, well then here's the URLs that are required, and it just goes through and includes those URLs, and then invokes some callback when everything's loaded. And because those URLs are generated on the server, they can include checksums. Because if you're on the browser, you don't have that information, it's incomplete information. You can't calculate a checksum if you don't have the contents of the file. So that's why it's really important to actually send down the full URLs with checksums to the browser. And we want to make sure everything was downloaded in parallel, and not even try to maintain execution order. So as soon as something downloads, that code gets executed. And there's tricks that you can make it so the execution order doesn't matter. So this is what the actual HTML output of the packager looks like. So if you, ignoring the whole asynchronous loading aspect, it'll just generate the normal link tags and script tags that you can include into your page, and it'll download those files for you. Nothing magic here happening. It's just what you would expect. But the interesting thing is if you want to download modules asynchronously. So from the server side, we send down some additional metadata to the browser that gets included on the page that basically says, for this module, here's all the URLs that you need to load. And all these URLs, of course, are based on how you bundled up your code. But it didn't, at runtime, it doesn't actually matter how you bundled up your code. It's just, here's a list of URLs that need to be included. And the loader just iterates through those URLs. And then if a particular module has a dependency on another module, it will then go to that module, figure out what URLs it that has, and it'll do that recursively to figure out all the URLs that have to be downloaded. So it's very simple implementation, but it's about as best performance you're going to ever get because the client's not making any decisions. It's all URLs with checksums, that sort of thing. So now we're going to talk about how you write your code. So writing code has a big influence on both code maintenance, but also just how you can deliver your code. So at its core, RaptorJS has support for modules, classes, mixins, and enums. And so the typical definition of a module is that it is basically an object that has certain properties that are exposed to the outside world. And if you're familiar with the module pattern as it was originally conceived, it also uses a function closure to actually, so you can have private variables, because any variables within the function closure can't be accessed by outside code, outside functions. It also is great for minification, so you can actually, having that function closure is very helpful for minification and for just having private variables. We also wanted to support inheritance. So you may or may not need inheritance. I mean, sometimes mix-ins are a better approach. It just depends on the use case. But setting up a prototype chain so that you have inheritance is something we wanted to support. And because it's not that difficult to support it. But it is true classical prototype-based inheritance and not anything unique. We also wanted to be able to lazily initialize all of the code. So the benefits of the function closure and in the way of defining a module is that you're really just putting all your code inside a function. You don't actually have to execute that function immediately. You can actually defer the execution until you actually depend on that particular module. So I'll kind of explain that when I show you the code just to make it clear. And the factory function I mentioned, it does give you a private namespace, and it does support minification. So here's the code for a module. And hopefully this is readable. But instead of using define require, we had to prefix it with Raptor because those two functions were already hijacked by other specifications, even though we didn't want to conform exactly to those specifications. But we also have some adapters to make it so that you can use the required define. It just depends on your use case. And so for now, just ignore the Raptor dot part and just focus on the define part. So the define part has two parameters. And the first parameter is the module name. The second parameter is the factory function. And now when this code executes, it actually does very little. So you send down the code to the browser. It executes this code. It's just going to associate the factory function with that name. And it just puts it into a hash map. It doesn't actually do anything beyond that. And then it continues on loading all your other code in your application. And inside the factory function is where all the interesting initialization happens. So inside your factory function, if you need to pull any external dependencies, you do it there. And because we're deferring the execution of this factory function, you don't actually have to have those dependencies be available at the time that the code is actually executed. But what's returned from the factory function is just an object, and that becomes your module. So Really very simple. You just return an object, that's your module. That's what other code will get when it calls require your module name. And your module can just have any number of properties that are needed. So for defining a class, it's basically the same thing. The only difference is that it's called define class. And what you return from your factory function should be a standard constructor function that has a prototype assigned. You can do this with AMD and CommonJS, so this is actually nothing new. The only reason we use the define class as a different function is it makes it easier to read the code and understand what's going to happen. It makes it more declarative. But you can just use define directly. It's just returning an object, and that happens to be a factory function. And just to make it clear, because I didn't mention on the previous slide, is that this factory function is only executed once. And it's only executed the first time the actual module is required. So you're only going to ever recreate one class object and one module object. Then it's stored off, and then that factory function is never executed again. So this is the example of how you do prototype-based inheritance. So it's basically the same thing as before. The only difference is that there's a second parameter that is the superclass name. And the framework will automatically set up the prototype inheritance so that the class prototype inherits from the superclass's prototype. We also have a nice little trick for actually invoking methods or properties and using properties in the superclass, is that the return class constructor function gets augmented with a reference to the prototype of the superclass. So you can use that same local variable that you return to call, in this case, rectangle.superclass. In this example, I'm only invoking the constructor function of the superclass, but you can invoke any property or method of the superclass. Yes, go ahead.
What is rect?
With the string or the actual? That's just for this example, it's just assuming that it has no meaning to the actual framework. It's just used by the parent superclass as its type. Maybe it was a bad example, but yeah, just ignore it. It's not actually needed. It's just a parameter to the argument to the constructor function of the superclass. So the nice thing about this is that we didn't want to change how you write your JavaScript. We want it to be as close to natural JavaScript as you're used to. Other frameworks like maybe XJS, they have their own syntax for defining classes that looks like nothing like what you would define a class if you were just to do it. I can't say nothing, but it definitely puts a wrapper around defining classes. And it's not just XJS. Other ones do that as well. We want to keep it as simple as possible. And I didn't point it out earlier, but using statics doesn't have to be a keyword. You just do statics how you would naturally do statics. So you just assign any static properties to your class to the variable that's returned. So mixins are also supported, and mixins are very straightforward in that it's very, instead of using the method call is just raptor.define mixin, you pass it in the mixin name. For all of these things, we use a factory function, and that's just so we can lazily initialize all these things and not have to worry about execution order. And for mixin, you just return an object, and that object, it becomes the mixins that can then be applied to other class. So at the bottom, you see raptor.define class. And if you have a circle button that has circle functionality, you can just apply the circle mixins to that particular class. And those properties will just be available to all of the instances of that particular class. You can apply mixins to both classes and modules. And it works the same way. The only difference, I guess, is that mixins apply to a class are applied to the prototype of the class, not to the actual instances of the class. So here's some code on how you actually use modules and classes. So the first part is obtaining a reference to the shapes module. So for that, you just say raptor.require shapes, and you get back a reference to the shapes. The thing I'm going to emphasize here is that when you call what the require shapes method actually does is that it does a lookup to see if that shapes module has been loaded. If it's not, it looks to see if that shapes module has been registered. And if it's been registered, it'll use that factory function that the shapes module was registered with and then execute it to actually get back the shapes module, and then that's what is returned from this function. The second part is actually creating an instance of a rectangle. So one nice thing that you can do with the module pattern is that you can expose methods that do the creation of the instances for you. So you don't care what the fully qualified name of the rectangle class was or where it even existed. You just have a factory function, or we'll call it a creator function just to avoid confusion, that you can invoke. And so here's, going back to the define module, you see here the create rectangle function. So that gets invoked with 2 parameters. Internally, that just calls new rectangle, and that's what gets returned. It just is a way to hide the implementation details of your actual module. So, but if you don't like that approach, you can still use the new keyword to create your classes. So you can call raptor.require, pass it in the class name. It'll do the same thing. It'll go resolve the actual reference to the class constructor function. If it doesn't find it, you'll get an error, but typically, in this case, it finds it, and it returns back the actual constructor function. Once you have a reference to the actual constructor function, you can use the new keyword to say circle equals new circle, exactly how you would do in normal JavaScript. So it doesn't try to change your coding style too much. And lastly, I want to show you the code for actually doing asynchronous module loading. So the first, the code in this example, all assume that everything was already loaded. So that the code has already been sent down to the browser, or it's already loaded into your JavaScript environment. But you may also have to handle the case where you want to use a module that may not have already, you may not already have the code loaded. In which case, you just change the syntax slightly. You pass it an array of modules that you want to load asynchronously, and then you give it a callback function. So internally, the framework or the library is going to do, the loader is going to do the same thing where it just looks for the metadata for those modules, figures out what URLs need to be loaded, and then actually downloads all those URLs, and then invokes the callback when everything has been downloaded. So pretty straightforward. And the last thing is there's another function called raptor.extend. The only difference here is it is a mixin, but you can create a mixin that gets applied externally to another class. So if you saw in the previous example, let me just go back to that real quickly. So define mixin. When you declare the class, in this case, it's declaring what mixins get applied. But what if you want to apply mixins to another class? You can use the raptor.extend. Now, the raptor.extend is very similar to the extend method that most of you have already used, where it just copies properties into the actual target object. The only nice thing here is that you pass in the name of the target instead of the actual object that you want to extend. And if the object has not already been loaded, the JSON object hasn't been loaded, it just registers the extension with the that factory function with the actual module. So when it's first loaded, the extensions will be applied. So it again goes back to the whole lazy initialization for everything. So with all of this, you create all this modular code, you create all this reusable code. You definitely want good documentation, and there's tools out there for that. But this is the example of the documentation we're currently generating. So we distribute a documentation tool with RaptorJS that actually will look at your code to figure out if you call define class or define module, it will actually then just generate the appropriate documentation for you. It does syntax highlighting, things like that. It's built on top of JSDoc Toolkit, which if I were to do it over again, I probably wouldn't use JSDoc Toolkit. But for the most part, it worked pretty well for actually analyzing your code, trying to extract information about it so you can generate documentation. So I also want to mention some tips for testing. So testing is something I think that's lagged a little behind in the JavaScript community because it's notoriously pretty hard because you have, of course, all different types of browsers. How do you test your code in all the different browsers? But if you ignore that part of it, just being able to test your raw JavaScript modules, you can actually do it pretty easily because the module itself is pretty independent, and in theory, it shouldn't have any dependencies on the DOM. You can have a module that has dependencies on DOM, but it's nice to create packages of utility classes and modules that don't have dependencies on DOM, and you can test them independently from the browser. And so for this, we're actually using Node.js, and in my IDE, I just configure an external tool launcher to actually run Node.js, and I'm using Jasmine to actually point it to all my test cases, and they execute in a fraction of a second. So there's no waiting to get the feedback on the actual test results. The only limitation there is that you're not actually testing your code in a real browser. But the nice thing about Node is that actually someone provided a module called JSDOM that gives you a simulated DOM, which allows you to actually write code that thinks that there's a DOM, but it's not actually the DOM. It's a headless DOM environment. It doesn't do any rendering or layout. Let's see what we're doing at time. Okay, we're getting close. But that's been really helpful because you can start testing some of your asynchronous code very easily. And then we are using Jasmine currently, but looking into Mocha, it's like the next. It looks like someone forked Jasmine, but it's very similar, but it improves on Jasmine. So I would recommend looking into Mocha if you're looking into creating a testing framework for your JavaScript code. And the other thing that we're doing is that we, of course, are running static code analysis. So we went with JSHint. You can use JSLint, but we found JSHint to be more flexible, more friendly to work with, because you can configure it to be based on the rules that you're interested in. And lastly, the other thing that we are using is a code coverage tool, which is also very helpful, because if you want to understand the quality of your code, it's helpful to know when you execute all your tests, how many lines of code, what percentage of lines you're actually hitting. So there's a tool called Node.js coverage that I recommend looking into. It'll basically take your JavaScript code, augment it with actual code that will then track the line number. So every time you execute a line of code, it'll then execute also the augmented code that basically tracks the line numbers. And then you get back some data that will say what percentage of what lines were hit, and then you can generate a report from that. So we're actually, to keep things simple, we took that data, converted it into a tool, the format that we have for our Java tools, so that the same reporters could be used inside our CI machines, and we can see what our code coverage is for our JavaScript tools. There's a few things that you'll run into is that you want to run within the JS DOM environment, you want to use the same augmented code, and you have to merge everything together, because the JS DOM actually is a isolated environment within Node. It actually runs within a different context, but that's more the implementation detail, just something to be aware of. So I just want to kind of wrap up with some of the design philosophies for RaptorJS, because it wasn't an easy task. There are a lot of things that were already out there. We tried to use it, but some of the goals for why we actually undertook this project was that we wanted to be able to have something that was modular and adaptive. So adaptive is the key word here that we weren't really finding in other tools. Now, I should mention that other tools, there are ways to do conditional code that inside your code. You can actually, there's like has.js is something that you might be familiar with, but it's all based on procedural code. And you'd have to parse out the code to figure out what parts of your code are conditional. We chose to go with the conditional code at the file level instead of actually within the actual code fragment. And the nice thing about that is it works for CSS and JS files as well. We also wanted to support object-oriented programming. So instead of just having modules that are just objects, we want to have just basic support for class inheritance, enums, mix-ins, that sort of thing. And we also wanted to encourage reusable code. So eBay is a big system, lots of applications. We wanted to be able to create a core set of modules that could be shared across teams. And we want to encourage teams to create modules that can then be used across by other teams as well. So like, if you have a team that's doing the searching, they might want to create a module that can then be used in other types of other pages, and then people using those modules don't have to worry about dependencies. We want to keep it as lightweight and fast, because we realize that if anyone's going to adopt this outside of eBay, it needs to work within their environment without adding overhead. We didn't want to add bloat. We want to keep it at the core minimum as possible and as simple as possible. And I didn't include any numbers here, but the gzip version of the actual define, require, classes, modules, mixins, that JavaScript library is only 2K, and the module loader is about 1K. So you're looking at like 3K of overhead. It's really not that much, and you can easily start using that functionality into your application without adding a whole lot of overhead. So we also wanted it to be framework agnostic, because eBay is a big company. We don't want to tell developers how they need to write their applications. We want them to choose the best tools that make sense for them. We wanted RaptorJS to be used alongside their code, so it could kind of have some way to share code amongst the different types of projects, but also just be flexible to support, work with jQuery and YUS sort of thing. API documentation was also something we wanted to support. So if you're sharing code, you want to be able to have documentation, and we wanted to make that as automatic as possible, having to at least, even if you didn't go into your code and actually add all the taglets to do all the documentation, to still be able to discover all the methods that are being exported from a module. So cross-environment, and that one is huge as well. So you have all the different types of browsers, and you have the server side and the client side. We wanted to be able to create modules that worked seamlessly across environments. And in order to do that, you have to be able to abstract away the underlying implementation oftentimes. Like just hypothetically, if you create a files module, that's going to be implemented completely different in Node.js as it is in Rhino, which is based on the JVM. But you can actually come up with a common API and then have the underlying implementation vary. And then you can start accessing files in either environment. So it's just kind of what CommonJS was striving for, which is to have a common set of modules across all environments. This does it in a way so that it can actually create modules that adapt to the environments that they're loading in. And the last thing is that we wanted it to be easily testable. So testable on the server. We want it to be modular. Actually, having modules that understand dependencies makes it easy to understand, easy to write test cases into code. Because if you want to test your code on the server, you just say test this module, and if that module has dependencies, they automatically get loaded by the module loader. And so that's all I have for now. Hopefully, you'll kind of follow us because it's not actually open source yet. So I was hoping we finally got the green light from eBay to open source it. But before I put it on GitHub, I just wanted to have some basic documentation so that people wouldn't be clueless if they looked at it. So that's the kind of what we're working on now. But we are actually using it inside the Raptor environment. Well, we call it Raptors, but the next generation stack at eBay. But it's being used by a lot of applications at eBay currently. So it's definitely in production. It has been tested. It works well. The performance is good. But follow me on Twitter for the official announcement. I can't promise, but hopefully within the next month or two possibly, we'll have the code on GitHub. So are there any questions?
So I know like RaptorJS has a sort of an NPM package where you can write RaptorJS out to the node.
Right.
Do you have any issue supporting that?
Yeah, and I think it doesn't hurt to support in the simple case of converting a CommonJS module into something that can be loaded on the browser. It converts it into a AMD style. The only problem I have with that is that we want it to be able to have a module resolved to a package.json file so that you can actually have additional information that tells the packager how this code needs to be packaged up and load it. But that doesn't mean that the two are mutually exclusive. You can have in the simple case, if it's just a module that's the same in every environment, just have it, write it in CommonJS and it'll be adapted to the other environment. So I think that I would like to see that happen. I would like to see the whole Raptor prefix drop off from all of this and then kind of merge with all the other things out there. It was hard for us to do because if we say that if we use the required define, we have to match the spec exactly. And I don't agree with all the decisions of all the different specs. So that kind of makes it difficult. And we could also improve things in areas without trying to maintain compatibility with all those specs. But then you can always create adapters to work with AMD and RaptorJS and CommonJS. Any other questions? Yeah, so we do have a ton of test cases with the actual core framework that tests all the module loading functionality, how you define modules. And we do ship with a few modules that you might find helpful. They're optional. And we have test cases for all those modules as well. But the whole thing about modules is that you pull in what you need. You don't, and you can pull in just as little as 2K and start getting some of the benefits of actually having modular JavaScript. And there are some other great tools out there. I didn't really talk so much about RaptorJS, but RaptorJS is a great tool. The only problem I have was that it had a very heavy loader that was coupled with the runtime library. And the nice thing is that you don't necessarily need a loader if you're just including the page as part of the initial load. And also the bundling system for that particular tool wasn't where we needed it to be. And it didn't support runtime packaging. But RaptorJS is good. I would definitely recommend if you're not using the modular JavaScript style to switch your code to make it to that style so that your applications are easier to maintain.
Does eBay package a file, or do you guys async load?
We do both. So a lot of the code, if it's needed as part of the initial page load, we didn't want to have to wait for a loader to be sent down to the browser just so we could start downloading the actual required code. So for that, we just use normal script tags and link tags. And for newer browsers, that's good enough because the code will be in newer browsers for sure. It will download the code in parallel and then just execute it in order. So it's giving the same thing that a loader would give you, but without all the overhead. But of course, after the page is loaded, we do have a loader that will then allow us to pull in additional code in a very efficient way. All right, any other questions? All right, well, hopefully you'll see it on GitHub soon. Please follow me on Twitter if you're interested, and feel free to find me later if you want to talk some more about it. All right, thank you.